Join Gorilla. Good afternoon, everyone. Welcome back to the session. In a previous session, we have started with the unit number 8, which is a string matching. We have done a new string matching and ribbon cap algorithm. Fine. So today we are going to start with the new topic, which is called as a finite automata. We have seen some basics of the finite automata, like what is a finite automata, what is the definition, and let us construct a finite automata for one of the pattern. Okay, so construct a finite automata for pattern is which is A. Text is this. This is given as a to find out how many types of text pattern is present in the text. So how we will start? Simple fundamental is here. Like this is a different than the TAFL. Okay, so see here. पहले क्या करेंगे, जो भी हमारे पैटर्न है ना, पैटर्न क्या है हमारे पास A. सो यहाँ पे 5 स्टेट्स होंगे, सॉरी 6 स्टेट्स होंगे, तब भी हम उसको 5 कैरेक्टर से रिप्रेजेंट कर पाएंगे. इनिशियली वी हैव स्टार्टेड विद 0, देन A B यहाँ पे लिख लिया मैंने. ओके, और सारे ट्रांजिशन दे दिए. 0 तो 1 पे चली जाओ, वापिस से दिया तो 2 पे, वापस B दिया तो 3 पे. नाउ 3 से अगर A दोगे तो 4 पे अगर B दोगे तो जाओगे. The final state. It means your pattern is matching. Whenever your pattern is matched, you have to the final state and you have to make a count कि कितनी बार ये पैटर्न यहाँ पे आ रही है, राइट? जितनी बार आएगी इतनी बार वो में जाएगा, अदरवाइज वो क्या करेगा, इन बिटवीन कहीं पे भी स्टक हो जाएगा. Now one is that from every state we have to take 2 inputs, A and B. Right? We have to take care of that. Now let us start with here. A, okay, 0 पे चले गए, 0 पे हो, A दोगे तो 1 पे चले जाओगे, राइट? अभी B पे क्या करोगे, आप सेल्फ लूप लगाओगे, क्योंकि 0 में से 2 इनपुट जाने चाहिए, राइट? One is a A and one is a B. A, if you give input A to 0 state, it is to 1. But what about B? What you will do? You will take a self loop. Next is what? Again A. पहले आप कहाँ पे थे, 0 पे थे, अब कहाँ पे पहुंच गए, 1 पे पहुंच गए. अगर A दिया 1 पे, A दिया तब कहाँ पे पहुंच गए, 2 पे, राइट? नाउ यू जस्ट सी, 1 पे क्या है, A दे दिया है हमने, राइट? 1 पे क्या है, A दे दिया. व्हाट अबाउट B? सो वी विल B into the previous, because here we have given a self loop. Okay, on the 0th state we have given a self loop as a B. So from 1 there will be 2 input, one is going to A and one is input B, which is coming back to 0 because there is a self loop. Now next is again A. Now you just see, A is we are having, A is done, right? But there is no. So from 2, one input, which is B. If you are at 2, if you give B input, you will reach to 3. What about A? You will give self loop. So यहाँ पे अगर आपने self loop दिया, that means you are able to calculate A. A means you are at index 2 only because of this self loop. Fine. Next you will go to B. अगर 2 पे हो, B input दिया, कहाँ पे पहुंचे, 3 पे, राइट? ओके, यहाँ पे आ गए. नेक्स्ट अगेन A, 3 पे है, A का इनपुट दिया, क्या आएगा, स्टेट, न्यू स्टेट आएगा, विच इज 4. फाइन. नेक्स्ट 4 पे हो आप, B इनपुट दिया, कहाँ पे चले गए, 5 पे. यस और नो? अगर 4 पे हो, यहाँ पे इनपुट B दिया, तो कहाँ पे चले जाओगे, 5 पे चले जाओगे. यहाँ पे चले गए, इट मीन्स 1 टाइम वी मैच द पैटर्न. एक बार फाइनल स्टेट में चला गया, दिस मीन्स वो एक बार पैटर्न मैच हो गया है. मैच हो गया A B, A ए बी मैच हो गया, राइट। नाउ यहाँ पे जहां पे भी बाकी है वो हम कंप्लीट करेंगे। 3 पे देखो, ए इनपुट है, अगर बी को कहाँ पे दोगे आप? ए पे क्या है, 3 पे क्या है, ए का इनपुट दिया, कहाँ पे चले जाओगे? 3 पे हो, 1 input A is already there. What about B? You have to backtrack to 0. Now, on the step 4, now you just say 0, 1, 2, and 3. All the states are having 2 inputs, A and B, right? Now, what about 4? 4 is having B, but what about A? We have to backtrack to 2, because in a 2 we have a self loop. Right? Now, we reach to the final state. This is not completed. This is not completed. We are having some characters left in the text. We have to check how many times this pattern is present. So what I will do, or one time we reach to the final state. अगर उसके बाद क्या आया, आप फाइनल स्टेट पे पहुंच गए, राइट। यहाँ पे अगर ए आया तो क्या करोगे, बी आया तो क्या करोगे? वी हैव टू आइडेंटिफाई, नो। अगर ए आएगा तो कहाँ पे चले जाओगे, बी आएगा तो कहाँ पे जाओगे, बी आएगा तो कहाँ पे जाओगे? 0 पे। अगर बी आया तो क्या करोगे, यहाँ पे 0 पे चली जाओगे। ओके, नाउ व्हाट अबाउट ए? लेट अस टेक दिस। अगर ए आया, अगर मैंने कहाँ पे लिया, 3 पे, अगर मैं 3 पे लेती हूँ, राइट, देन ए बी, बट दिस इज नॉट, पैटर्न इज मैच्ड, पैटर्न इज नॉट मैच्ड, राइट। अगर मैंने 3 पे लिया, यहाँ पे सपोज 5 से मैंने क्या किया है, 2 पे लिया, सपोज लेट्स चेक फॉर 2, यहाँ पे ओके, मान लो मैंने यहाँ पे ले लिया, ए आएगा तो कहाँ पे चले जाओगे, 2 पे सपोज, ओके। वापिस से आया तो 2 पे रहोगे, बी आया तो 3 पे, वापिस से आया तो 4 पे, वापिस से आया तो कहाँ पे चले जाओगे, 2 पे, वापिस बी आया तो 3 पे, वापिस से आया तो 4 पे, एंड देन अगेन बी आया तो 5 पे। नो, एक बार कंप्लीट हो गया, राइट। वन टाइम वी हैव कंप्लीटेड। नेक्स्ट चैप्टर A is there, so we are having two choices. No, we are having two choices. You can redirect A to self loop, right? Here the self loop of A is there, so what you will do, you will redirect here. Or another way is what you will redirect to this node 1. जहां से भी A निकलता है आप वहां से ले जा सकते हो, but make sure that all this text, whenever the pattern is matched, you will reach to the final step. You have to make count. Suppose आप मान लो मैंने क्या किया है, ये 5 है ना, यहाँ पे दे दिया है, अभी ये अभी थोड़ा बहुत चलेगा। अभी मैंने क्या किया है, 1 पे मैंने रिडायरेक्ट किया। जब 5 पे जाके जब आपको ए इनपुट मिला तो मैं कहाँ पे रिडायरेक्ट कर रही हूँ, स्टेट 1 पे, ओके। नाउ अगर स्टेट 1 पे जाऊंगी तो यहाँ पे 1, राइट। अभी वापस से आया तो 2 पे जाऊंगी, देन बी आया तो 3 पे, वापस से आया तो 4 पे, वापस ए आया तो कहाँ पे जाऊंगी, 2 पे जाऊंगी, वापस बी आया तो 3 पे, then 4 and 5. This is the only difference. One node only we changed and we are able to get the answer. If you go to the 0th node, then what will happen? Let us check. If you go to 0th node, okay, 0. If you redirect when A is there at the final step, if you are having A in the 0th step, if you redirect to 0, so here A, you will reach to 0. Again A, you will reach to 1. अगर बी आया तो वापस 0 पे चले जाओगे, वापस ए आया तो 1 पे, फिर अगर ए आया तो 2 पे, तो 3 पे, 4 पे एंड 5 पे. All are possible. You can redirect to anywhere where there is a. जहां से भी ए निकलता है आप वहां पे ले जा सकते हो, but make sure that your pattern will match. Whenever there is a pattern, you reach to the final step. Okay. So this is how you can do the pattern matching. So it's up to you where you want to denote. Fine. Rest of the
Excuse
other
me,
things
ma'am.
are yes.
Ma'am, from 4 to 2, there is path of A, but I think it should be from 4 to 1.
You can take 4 to 1 also, 4 to A also, because there is a 2 having a 2. We
Yes,
are
ma'am.
having a
So
self
you
loop,
are
so you can
considering
take.
self loop
Now,
also.
yes, see in this pattern matching, I have observed that you have to take these characters once you reach to the final state, right? And then you are trying to match this figure. Then you take this text and you will try one by one character you will take and you will trace it. And you try to identify whether there is a pattern you are able to reach to the final state or not. Okay. According to TFL, if you are comfortable with to do like that, that is fine. Okay. Because everyone is having a different method to explain. So you can use your method, that is also fine, but make sure 2 times we have reached to the final step. Okay. You can make your finite automata by yourself, that is fine. One thing you have to remember, you have to write down pattern on this transition. Okay. On this arrow you have to
Yes,
write, and
ma'am.
rest of the transition you can do it by yourself. Okay. There is no at all wrong. And 2 times we are able to find the answer. So how we will write it down? First of all, you have to build a state transition table. अगर 0 पे हो, 1 ए इनपुट दिया तो कौन से स्टेट में जा रहे हो आप? 1 पे. बी है तो 0 पे ही रह रहे हो. 1 है, 1 पे दिया तो कहाँ पे जा रहे हो? 2 पे. अगर बी है तो 0 पे, राइट? 2 पे हो आप. ए दिया तो 2 पे ही रहोगे, बी दिया तो 3 पे जाओगे. 3 पे क्या है? ए दिया तो 4 पे जाओगे, 3 दिया तो, बी दिया तो 0 पे. 4 पे क्या है? ए दिया तो 2 पे जाओगे एंड बी दिया तो 5 पे. 5 पे here it is a 0 and 2, right? Sorry, here it is 2 0. Just a second. Okay, I have to draw it again. It's fine. It is automatic crashed. So just a second, I'm sharing the screen again. Okay, so let me start it here. Okay, you will redirect here to B. Now. Automatic crash. I don't know why. There is some problem with this. It is auto saved only, but I don't know. Okay. So let me explain it again. If someone is having any doubt, then it's fine. So let us start with A. 0 पे हो, A का इनपुट दिया, 1 पे चले गए, वापिस A आया. नेक्स्ट कैरेक्टर इज A. 1 पे हो, A दिया, 2 पे चले गए, अगेन A आया. A तो यहाँ पे है नहीं, राइट? एवरी इनपुट और एवरी स्टेट वी हैव टू टेक अ 2 इनपुट. 0 पे A दे दिया, B का क्या करोगे? सेल्फ लूप चलाओगे. 1 पे है, ए दे दिया, 2 का बी का क्या करोगे? सेल्फ लूप. और यू कैन गो बैक टू द जीरो नोड. नाउ from 2 b is already there. For a we will do the self node. So what are we now? A this is done. A 1 2 and 3. 3 पे चल सॉरी 1 2 and 2. नेक्स्ट क्या है? b. 2 पे हो, b पे जाओगे तो 3 पे आ गए. नेक्स्ट a. 3 पे हो, a दे दिया, 4 पे चले गए. 4 पे हो, बी दिया, 5 पे आ गए, फाइनल स्टेट में आ गए. वन टाइम. सो वन टाइम पैटर्न इज मैच. ए बी ये मैच हो गया वन टाइम. ओके, पैटर्न मैच हो गया. नाउ नेक्स्ट, अभी ये खत्म नहीं हुआ है. फाइनल स्टेट के बाद भी 2 पॉसिबिलिटीज है. या तो फिर ए आएगा तो कहाँ पे जाओगे, बी आओगे तो कहाँ पे जाओगे, ये आपको फाइंड करना है. बी आओगे तो यू आर श्योर दैट वी विल रीडायरेक्ट टू, you can take it, but we have to make sure, we have to check it again. So for 3 a is there. For b, when there is a b, we will go back to 0. For 4 b is already there. What about a? Sure, it is a self loop, so you will give a. Now फिफ्थ पे जब आप हो, यहाँ पे a का इनपुट आया, तब कहाँ पे जाओगे? या तो 1 पे जाओगे, 0 पे जाओगे, या फिर 2 पे, राइट? सो लेट अस चेक इट. अगर a आया, सपोज मान लो कि मैं कहाँ पे चली गई? 1 पे. सपोज अगर फिफ्थ पे वापस a आया तो मैं कहाँ पे चली गई? 1 पे. फिर वापस a आया तो 2 पे, b आया तो 3 पे. 3 पे हूँ, a आया तो क्या कहाँ पे जाऊंगी? 4 पे. वापिस a आया, 4 पे a आया तो 2 पे जाऊंगी. देन 2 से b 3 पे. देन 3 to a 4. 4 to b 5. सेकेंड टाइम यू रिच. नाउ अगेन वापिस a आया तो कहाँ पे जाऊंगी? 1 पे. वापिस a आया 2 पे, b आया तो 3 पे, right? Now there is no possibility. How many times you reach to the final state? 2 times. So this is how you have to check कि चाहे जैसे भी आप ड्रॉ करो for this topic. Okay, simple is that जैसे भी आप ड्रॉ करो, जब भी पैटर्न आए तब आप फाइनल में पहुंचना चाहिए. जब भी आपका पैटर्न मैच हो रहा है, it means you reach to the final state, then only it will be acceptable. Otherwise, how you are drawing, that is up to you. This is the simplest way I can explain, okay, because this is the pattern matching. Some things are different than the TAFL, right? Because in TAFL we are having some statements like A star, B star, A plus, A, B star, something like that. But here we don't have any kind of this. So we have to just do it by ourselves only, based on the assumption, and we have to trace it. Okay. Based on that, we have to prepare this transition table. Now let us prepare the transition table. Now 0 पे हो, a का इनपुट दिया तो 1 पे गए, b का इनपुट दिया तो 0 पे ही हो. 1 पे a है तो 2 पे जाओगे, b दोगे तो 0 पे. 2 पे हो, a का होगा तो सेल्फ लूप, दैट इज 2. b होगा तो 3. 3 पे हो, b दिया तो 0 और a दिया तो सॉरी a दिया तो 4, b दिया तो 0. 4 पे a दिया तो 2 पे जाओ, दिया तो 5 पे. 5 पे क्या होगा? b दिया तो 0, a दिया तो 1. Then now one some steps also you have to write it by yourself. So here I will write down the pattern, text and pattern. Or let me take the table. 1 2 3 4. Okay, so here I will write down the pattern. Sorry, text. Text is what? A, 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 B, A, B, A, A, B. Okay, this is your text. This one is your pattern. How you will match A, B, A, B? You will match these two characters. Match these two characters. Is it matching? Yes. Next, match the next character. Is it matching? Yes. Match the next character. Is it matching? No. So what you will do, you will shift your pattern by 1. So here pattern is shifted. Again you will match A and A. Is it matching? Yes. A and A matching. B and B matching. A and A matching. B and B matching. All the characters are matched. Right? So one time we have done. Again you will shift the pattern by 1. It is very small and I don't know. This is the better way, I guess. Okay. So you will try to match this. If it is not matched, then when you will shift by 1. Match it. Yes, all the characters are matched. Right? Now you will shift your pattern by 1 bit again. Again you will match A and A matching. A and B is not matching. So what you will do, again shift by 1. B and B. B and A, is it matching? No. Again you will shift by 1. A and A matching. A and B is not matching. Again you will shift the pattern by 1. A and A matching. A and A matching. B and B matching. A and A matching. A and B not matching. Again you will shift the pattern by 1. A and A matching. A and B is not matching. So again A and B, this A and B is not matching. So simply what you will do, sorry, A and A matching, A and A is matching, B and B is matching, A and A is matching, B and B is also matching. These 5 characters are matching. So again, second time we have matched the characters. Now again shift by 1. A and A matching, A and B is not matching. Again you will shift the pattern by 1. B and A, is it not? It is not matching. So what you will do, you will shift again. A, A, B, A, and B. So this A and B not matching. Right here it is not matching. So simply you will exit. Right. So how many times we have repeated? How many times we have done this? 2 times. The number of count, it will be 2. 2 times the pattern is found. So is it clear now? How to? This is the entire example. Okay. This also you have to prepare. And this is the entire example. I hope this is clear to everyone. Or is there any doubt? Then please ask. Anyone is having any doubt in this finite automata? Pattern matching through the finite automata. Write down yes or no. If it is not clear, then please tell me. I'll explain it again. Everyone is clear with this? What about others? Shyam, Anjali, Vishal, Ankit, Rahil. So this is the second example. You have to try it by yourself. Okay, note down this pattern and text and try to complete it at your home. Okay. So everyone please note it down. This example you have to solve by yourself. Next algorithm we are setting, that is called as a KMP algorithm. Name of the algorithm is a Morris and Pratt. There are three different scientists. Not Morris and Pratt. KMP algorithm. Fine. So basically KMP algorithm we are using to improve the time complexity of naive string matching. So there are some disadvantages of naive string matching. So we will try to reduce the time complexity using this approach. So first of all, let me tell you one thing. Suppose there is a string and one pattern is available. And the pattern is what you have to match DEF. Aim is to find whether this pattern is available in the string or not. If it is available, then you have to return the index. Fine. So if you use a naive approach, naive string matching algorithm, if you are using, then what you will do, you will compare first letter of the string with the first letter of the pattern. Is it matching? No. Then you will shift your pattern by 1. Now you will match A and D. Is it matching? No. So you will match A, D and C. Is it matching? No. Then you will match. So then after D will go here. Or let me tell you one. First of all, you will check D, E, F. Is it matching? No. So what you will do, you will shift the pattern by 1. Okay, I am shifting here. D, E, and F. Match the character. D and B matching? No. So again, you will shift the pattern by 1. D, E, and F. C and D, is it matching? No. Again, you will shift the pattern by 1. D, E, and F. Now, D is matched. Yes, match the next character. E is matched. F is matched. So I guess in index 4, it is the answer, right? So we are doing this. See, this is the simplest example, right? If one by one characters we are matching, if it is match is found, we will match the next character. Otherwise, we will shift the pattern by 1 bit. And time complexity will be what? Order of n into m. Now, let me take one another example and tell you how exactly it is a time consuming. Why it is a time consuming? Because every time, whenever, suppose if we are having 5 characters in a pattern, and somewhere we found that 4 characters are already met, but because of one character we have to again backtrack, right? Backtracking is what? It is a time consuming process. Again, you have to check for the same and sync, right? So doing the same process in a repeated manner, it will take a lot of time. We don't want to waste this time, so we are using the KMP algorithm. But let me take that example also. Suppose this is your text. A, B, C, D, A, B, C. This is the text we got here. Pattern is A, B, C, D. Suppose I is starting from here, J is starting from here. Same thing we are doing, okay? We are comparing one by one letter. When characters are matching, we are doing the shifting. Okay. A and A is matching. A and A is matched. Yes. So what you will do? You will increment I. Okay. I and J both are increment. I is here. J is here. B and B, is it matching? Yes. So what you will do? Again increment I. Simply, if the one characters are matching, then what you will do? You will match the next character. Same here, B and B is matching, right? So I'll do, simply I have taken I and J loop. Why we have to backtrack, that I'll explain. Okay. Now again, C and C, is it matching? Yes. So you will check the next character. You will compare these two. D and D, is it matching? Yes. So you will go back to the next character. Now you just see A and F, is it matching? No. When it is not matched, then again what you will do, here let me write down. Now this character, the one character is not matching, you will shift the pattern by 1 bit. Yes, by 1 you have to shift. Now just see, I we reach to the 5th. Again you have to backtrack and you will reach to the index number 2. So every time whenever there is a mismatch of the single character also, you have to backtrack to the previous index, right? So this is time consuming. यहाँ पे देखो 4 कैरेक्टर तो मैंने ऑलरेडी मैच कर दी है, सिर्फ एक का ही नहीं मिल रहा है, राइट? सो अगर ये एक नहीं मैच हो रहा है, अगेन वी हैव टू बैक ट्रैक एंड वी हैव टू स्टार्ट फ्रॉम द सेकंड इंडेक्स, राइट? सो वी हैव टू डू द सेम थिंग अगेन एंड अगेन. इज देयर एनी सॉल्यूशन फॉर दैट? लाइक ये चारों मैच हो गए तो उसको कहीं और पे रख दो और फिर एक ही कैरेक्टर को हम मैच करवाए. एफ ही मैच नहीं हो रहा है ना, अल्टीमेटली क्या है, ये एफ की वजह से ही हमें स्ट्रिंग नहीं मिल रही है, वापिस से हमें चेक करना पड़ रहा है, राइट? सो इज इट पॉसिबल लाइक आई स्टोर एबीसीडी इन अ सेपरेट वे एंड जस्ट चेक एफ विथ ऑल अदर थिंग? सो नो नीड टू चेक अगेन एंड अगेन. एबीसीडी को तो मैच नहीं करना पड़ेगा ना वापिस से, 4 कैरेक्टर तो ऐसे ही स्टोर हो गए, सिर्फ एक कोई सबके साथ चेक करना है. So is there any way? Yes, there is one kind of way which is called as a KMP algorithm, Knuth, Morris and Pratt algorithm, to save the timing of again and again backtracking and comparing the same elements again and again. We have to use a KMP algorithm in which we are going to pre-process the string or pre-process the pattern such a way that if the same string is repeating again, then we do not need to check it. Fine. So KMP में हम कैसे वर्क करेंगे? You have to build a pi table. Okay, so just we will take the glimpse of this pi table, how to prepare it. Okay, suppose ये मेरे पास है pattern. Right now we are taking only pattern. Okay, now you have to find out the prefix and suffix of this pattern. Prefix and suffix. Prefix means what? Subset of a, it is a subset of a pattern, but we are going to consider it from the left hand side. It is a subset of pattern from left side. Prefix means what? From any character. B है उसके पहले क्या कैरेक्टर है? प्रीफिक्स. प्री पहले क्या आता है वो लिखना है, राइट? यहाँ पे C है, C के पहले क्या आ रहा है? ये सारे कैरेक्टर्स आ रहे हैं तो उसको हम बोल सकते हैं ABCD. AB को हम बोल सकते हैं वो उसका प्रीफिक्स है, राइट? So this is a subset. Prefix is what? It is not the entire string, it is a subset of a string. Subset means what? सारे के सारे कैरेक्टर्स नहीं आएंगे, उससे एक कम होगा ऑलवेज. ओके, सो प्रीफिक्स एंड सफिक्स में लेंथ एक कम होगी, सारे के सारे कैरेक्टर्स नहीं आएंगे. In a suffix, it is a subset of pattern, but from the right hand side. Okay, now tell me the prefix here. वन इज ए बी भी हो सकता है प्रीफिक्स, ए बी सी भी हो सकता है प्रीफिक्स, ए बी सी डी भी हो सकता है, ए बी सी डी ए भी हो सकता है, ए बी सी डी ए बी, और last one is a substring, is a prefix or not? Last one, this one, is it a prefix? A B C D A B C, is it a prefix? No, it is an entire string, so this is not our prefix. तो ये हो गया. Now suffix में क्या करेंगे? लेफ्ट हैंड साइड से काउंट करेंगे, लास्ट में से. C हो सकता है suffix. Then we are writing not CB, we will write it as a BC. Okay, so you have to remember this. We write B, then ABC, then DABC, then CD ABC, then BCDA BC. Now ABCD ABC is not a suffix, so you have to find out prefix and suffix of this pattern, and based on this pattern you have to prepare the pi table. Okay, and this pi table is called as a LPS table, longest prefix suffix table. Okay, so how you will build it? Let me take this example. This is the pattern we are having, and we have to prepare the pi table. We will prepare the pi table. Okay, so let me write down the here AB, AB, AD, A. This pattern, right? Now, see, single character A होगा तो कोई prefix suffix होगा उसका epsilon. Prefix and suffix will be what? Only the epsilon. What will be the length of matching character? Here it will be 0. So here you will write 0. If there is a single character, there will be no prefix and suffix. So longest length will be what? 0. Now you will take two characters A, B. AB is a prefix, right? If you take this AB, what will be the prefix of? One by one we will start with one character, then we will take 2, 3, 4, 5 and 6. For all these characters we will find the prefix and suffix. Now take a two combination AB. Prefix is, one is epsilon, one is A. Suffix means, suffix क्या होगा AB के लिए? AB है, right? Suffix will count from B. So epsilon and B. Try to match. Is there any characters matching? ये prefix और suffix को match कराओ. Is there any characters matching? No. So here length will be what? 0. Next you will take three characters A, B, A. A, B, A के लिए prefix suffix find करो. One is epsilon. A, A, B. Suffix will be A, B, A. Right? Now tell me, is there any character matching in this prefix and suffix? A, A. What is the length of this character? So here maximum length is what? 1. I'll tell you the shortcut way also, but just wait for it. Okay, now. Next you will take AB, AB. You will take the substring. Find the prefix and suffix. One is epsilon, A, AB, ABA. For suffix, it will be B, AB, BAB. Now find the matching characters. Is there any matching in prefix and suffix? AB is matching. Length क्या है उसकी? 2. Okay. So AB, AB. यहाँ पे आ गए. AB, AB. यहाँ पे क्या आ जाएगा? 2. Then AB, AB, D. Prefix and suffix find करो. Epsilon, A, AB, ABA, ABAB, right? This is the prefix. What will be the suffix? Epsilon, D, DD, ABD, BABD. Is there any characters matching? No. So you will simply write down 0. Next is what? The entire string A, B, A, B, D, A. For this entire string, find the prefix and suffix. Epsilon, A, AB, 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 D. Now for the, अगर ये आएगा तो फिर entire string आ जाएगा. It is not a substring. Now suffix A, DA, BDA, then AB, DA, BA, BDA. Now tell me, how many characters are matching? AB, DA, only one character, that is this A and A. What is the length of a character? 1. So here I will write down is 3, 0, and 1. Okay. Easiest way how to find it? Let me tell you. A, B, A, B, D, A. 1, 2, 3, 4, 5, 6. Okay. यहाँ पे मुझे बताओ ए कहीं पे अकर हो रहा है? ए का अकरेंस कहीं पे है स्ट्रिंग में? कहाँ पे है? ये यहाँ पे तो 0 आएगा, राइट? यहाँ पे 0 लिख. ये ए के बाद कहीं पे ए आ रहा है तो क्या करोगे? ये जो इंडेक्स नंबर है वो वहां पे लिख लोगे. ये इंडेक्स नंबर है 1, यहाँ पे लिख लोगे. अगेन यहाँ पे आ रहा है, देन यहाँ पे जो भी ब्रेक आ रहा है तो स्टार्टिंग फ्रॉम दिस ओनली. बी कहीं पे वापस आ रहा है क्या? ये छोड़ के यहाँ पे आ रहा है. यस, यहाँ पे रख दोगे 2. डी रिपीट नहीं हो रहा है, बी रिपीट नहीं हो रहा है, इट मींस यू विल राइट डाउन 0. सिंपली ए बी रिपीट हो रहा है, यहाँ पे ए बी भी है, सो ये इंडेक्स लिख लो 1 2 1 2, राइट? डी कहीं पे भी नहीं आ रहा है इस स्ट्रिंग में तो वहां पे 0 आएगा, उसका अकरेंस नहीं है, रिपीट नहीं हो रहा है डी, सो वी विल राइट डाउन 0. एंड दिस ए बी अगेन इट विल बी 0 0, एंड दिस ए मींस पहले जो भी है वो हम लेंगे. This is the easiest method. This will you will get when you do some practice of the pi table. Okay, but generally in exam you have to prepare this pi table. Okay, this pi table, and then you have to do the tracing. The tracing part we will do it in our next session. But let me give you some other string and find out the pi table for it. So everyone note down the string A B C D A B E A B F. Everyone please note it down. ये पाई टेबल कैसे क्रिएट करना है ये समझ में आ गया सबको? और is there any doubt? It is an online mode only. TFL is only online mode. So this, for example, you have to create a pi table for this. Okay, so everyone please take a note of this. You have to prepare a pi table. In our next session, we will check it first and then we will go for the example. Okay, so I hope this is clear to everyone. This pi table, how to create this pi table is clear, right? So everyone please note down the string, take a screenshot, and then I'll wind up the session. Today we have completed finite automata and we have understand the basic of this KMP algorithm. This we will again understand in the next session. Fine. So thank you everyone. I hope you enjoyed this session.